Happy day, students. Welcome to San Academy Pallikaranai, class 10 mathematics. We are going to learn the last part of this session, uh, introduction to trigonometry. Already we learned about the trigonometric identities. We are going to learn in these trigonometric identities. You know that one sin square a plus cos square a equal to 1, cosecant square a minus cot square a equal to 1, secant square a minus tan square a equal to 1. Yes, I hope you all understood part 7 and then you watch the video also. Now let me see the next one is how the exercise sums 8.4 based on the trigonometric identities. Okay, let me solve the trigonometric identities exercise 8.4. So first sum, if you see, you have to know in this we are having this is very important exercise. First exercise, second exercise, third exercise only for 1 mark, 2 mark. But this exercise is for compulsory. You will have the 3 marks or 4 marks. Okay, so you should have the compulsory. You should know the where we have to apply what. Mostly prove that only sums is type of sums and all, or prove that or express the trigonometry. If you see the first question in this, sin A, secant A and tan A in terms of cot A means you should get all sin A also you should convert into cot A, secant A also you have to convert into cot A, tan A also convert into cot A. Tan A is very easy. Tan A is nothing but tan A is equal to 1 by cot A. Okay, but secant and sine, what is the relation you should see? Secant you have to convert into cot A means as we know that one secant square one identity secant square A minus tan square A is equal to 1. Yes, this identity and who is the reciprocal of tan? Cot is the reciprocal of tan. By using this one we can able to find out converting as a secant A into cot A. In terms of cot A we can able to convert. Okay, first let me see the sin A. What is the relation between sin A and cot A? And sin A and cot A relation is sin A, as we know that when sin A is 1 by cosecant A. And we are having the relation is cosecant A is equal to minus cosecant square A minus cot square A is equal to 1. We know that relation. So based on this one, we can able to find out you should see the identities we can able to apply, or we can also able to apply the ratios also, reciprocals also based on the relation, and then sometimes we can able to apply the complementary also we can. So here we are going to apply identities and ratios and their reciprocals. See now for example, sin A reciprocal is cosecant, and we are having connection between cosecant and cot identities. Cosecant square A minus cot square A equal to 1, that one. So now first let me see the cosecant square A plus 1 plus cot square A. So what is a 1 by cosecant square A? Reciprocal it. 1 by cosecant square A equal to 1 by 1 plus cot square A. Then 1 by cosecant is nothing but sine. 1 by cosecant is nothing but sine. So sine square A. 1 by cosecant is sine square A equal to 1 by. Then square if we send that side root over. So root over 1 is 1. Root over 1 by 1 plus cot square A. Okay. By using this identity, we have converted sine A in terms of cot A. Okay. Now next one is we are going to convert in secant A. Secant A sine A we got. Secant A convert into what is that? Secant A convert into cot A. Sine, as you know that one, tan A is sin A by cos A. Cot A is cos A by sin A. Tan A is 1 by cot A, you know this one. Now we are having one more identity. Secant square A equal to 1 plus tan square A. Tan is what? 1 by cot. So take LCM cot square A plus 1 by cot square A. Then secant square A, square if you say in that side, root over cot square A plus 1 by cot A. So this is very easy to do. You should know the link between reciprocals and the identities. Then it will be easy to find out this one. Because we are going to convert sine into cot. Then sine reciprocal is cosecant. We are know the identity cosecant square equal to 1 plus cot square. Based on this one, it is very easy to convert at a trigonometric ratios. Now let me see the second sum. Second sum also same like that. Write all the trigonometric ratios in terms of secant A. So from sine, cos, secant, secant means secant only. Sine, cos, tan, cosecant, secant, cot. All you should convert as a secant A. As we know that one, we'll take first one is cos. Who is the reciprocal of cos? 1 by cos A. So you will get first one. Okay, first one you will get. Now, if you see the second one, this is the first one. First one you got. Now, if you see the second one, use the identity sin square A plus cos square A equal to 1. 1 minus cos square A. What is the cos? 1 by secant. Apply. We have to convert into sine in terms of secant A we have to bring. So 1 minus 1. So take LCM. Secant square A minus 1 by secant A. What is a secant square A minus 1? Root over secant square A minus 1 by secant A. So we converted as a sine A into like this. Now we have to convert sine over cos over. Second one also over. Second one is, this is the second one. 6 ratios we have to make all are secant A, secant A. Third one will take tan A. So how to convert tan A? Tan square A plus 1 is equal to secant square A, we know very well. Then plus 1, if you say that side minus 1, square will go that side that. So third one also we have converted as a what is that? Tan A in terms of secant A. Now we are going to convert as a cot A. What is the cot A? Cos by sin. Cos is 1 by secant. Already we know that from the equation 2, we'll get the secant sin A is root over secant square. Then secant cancel. Then 1 by root over secant square A minus 1. And now cosecant. Who is the reciprocal of cosecant? Sine. Already you know the sine. Then sine is root over secant square A minus 1 by secant A. Then you got now, this is fourth one. Now this is also fifth one. So all the ratios, if you see, cos means 1 by sine, sine means root over secant square A, 1 by secant, sine means root over secant square A minus 1 by secant A, and tan means tan is equal to root over secant square A minus 1, and cot means 1 by root over secant square minus 1, and cosecant is, what is a cosecant? Cosecant is 1 by sin A. So sin A is reciprocal, if you do, we'll get secant A is secant A only. Secant A equal to secant A. So all the 6 ratios we are converted in terms of secant A. So you can convert any one of the ratios into other ratios. Is it possible by using these identities as well as their reciprocals and their trigonometric ratios? Let me see the third sum. From third sum is very important. Sin square A 63 degree plus sin square 27 degree by cos square 17 degree plus cos square 73 degree. Sin square 63 degree plus sin square 27 degree means, what is a 63 degree? Here how we can able to write? In third exercise we learned 63 degree 90 minus 27. So 90 minus 27 is cos 27. Then cos square plus, if you see the first one, cos square theta plus sin square A, cos square A plus sin square A is equal to 1. Same way down also converted. 17 means 90 minus 73. Then sin square 73 plus cos square is 1. Then 1 by 1 is 1. Okay. Now second sum. Same way. 25 convert as a, what is that? 25 is nothing but what, how you can able to try? Any one you convert. Sin 25 is 90 minus 65. Then cos 65 into cos 65, cos square 65. Same way here cos 25 is sin 90 minus 25. Sin 90 minus 65. Then cos 90 minus 65. Then sin 25. Then sin 65 will be become as a cos square. Here they convert as a 25. You can convert either 25 or 65 also, but we have to use your complementary angles. Now next one is choose the correct option, justify your answer. It is like the MCQs. 9 secant square A minus 9 tan square A. So here 9 is the common. If you take 9 secant square A minus tan square A, we know that the answer is, identity is 1, then 9 is the first. Then option B is the correct. 1 plus tan theta plus secant theta, 1 plus cot theta minus cosecant theta. So now convert this like this is there, mostly convert into in terms of sine and cos. Then it will be easy to do the sum. What is the tan sine by cos? Secant 1 by cos. Cot cos by sine. Cosecant 1 by sine. Take LCM. Here cos theta is LCM. Here sin theta is LCM. Then if you see here, they applied A plus B. Cos theta plus sin theta is A. Cos theta plus sin theta is A, and 1 is the B. So A plus B, A minus B. Means A square minus B square. Then here again A plus B whole square. A square plus B square plus 2AB minus 1. So as we know that when sin square plus cos is 1, 1 plus 1 is 2. So 2 is the common if you take out. What will be 2 is a common if you take out. 1 minus 1 plus 1 will get cancelled. 2 sin theta cos theta by sin theta, then cancel. 2 is the answer. Then LH, we got the option is 2 is the option, that is option C. Secant A plus tan A 1 minus sin A. So how we can able to convert this? Also you can able to convert into in terms of sin and cos. Mostly take in terms of sin and cos. It will be easy to do the sum. So secant is 1 by cos. Who is tan sin by cos? Then already sin is sin. So take LCM here also 1 plus sin. Here again apply A plus B, A minus B. A is 1, B is sin. So a square minus b square. 1 minus sin square is nothing but cos square a. We know the identity. Then 1 cos will get cancelled. Cos a. Then option D is the correct. So 1 plus tan square a by 1 plus cot square. Here tan also convert into sin square by cos. Same way cot also cos square by sin. So you take LCM. This cos square 1 by 1. Then sin square by cos square will come. It's nothing but tan square. It's option D is the correct. Now let me see from fifth sum. Question number 5 is a very important one for 4 marks. So you should practice more twice or thrice each and every sum. Then only, because in trigonometry each and every sum will be different. Not, we are not going to apply the same. But you should logically think where we are to apply the identity, where we are to apply the to get the RHS, where we are to apply the identity, where we are to apply the reciprocals and their ratios. Okay, if you see the first sum here, in this first one, cosecant theta minus cot theta whole square is equal to 1 minus cos theta by 1 plus cos theta. So you should here apply LHS, you can take RHS also you can prove. Sometimes RHS also we can take, LHS also we can prove. So 1 by cosecant means 1 by sine. Mostly convert as a sine into cos. Then it will be easy to get the answer for you. So and again cot means cos by sine. What is LCM? Sine is the LCM. Then 1 minus cos. Then square is the common. So separate it. Numerator square, denominator square. Then 1 minus cos we can write as a minus b whole square form. Or sine square we can write as a 1 minus cos square theta. What is a 1 minus cos square theta? A minus b, a plus b. So a minus b cancel. So 1 minus cos theta by 1 plus cos theta. You got the, what you got? RHS you got. We can take RHS also, we can prove LHS here. Okay. Now if you come under, next one is second sum. Cos A by 1 plus sin A, and then 1 minus sin 1 plus sin A by cos A. Take LCM. Whenever like this is a take LCM. It is not possible to take a RHS here, because 2 sequence is a very only one ratio to get the biggest LHS. So LHS is only possible to take here. So what is LCM? 1 plus A, 1 plus sin A into cos A. So cross multiply. Whenever like this, do cos A into cos A, cos square A, 1 plus sin A into 1 plus sin A, 1 plus sin A. And apply here A plus B whole square. A square plus B square plus 2AB. Cos square A plus sin square A is 1. Already 1 is there. Then 1 plus 1 is 2. 2 is the common. Take 2. 1 plus sin A, and numerator also now 1 plus sin A, denominator also 1 plus. Then 2 by cos. What is the cos sequence? So we got the RHS, 2 sequence. Hence proved. Okay. Now this is very important sum, third sum. If you do 3-4 times only, you will understand this sum. So you make practice this sum to till you are perfect with this one. And it's very important sum solve. This fifth section is very repeated sum each and every exercise. So every sum is very important here. Tan theta by 1 minus cot theta. Convert. Whenever tan, cot, cosecant, secant is a convert as a sine into cos. Okay. So tan is nothing but sine by cos. Same way cot is cos by sine. So convert into tan in terms of sine theta by cos theta, cot into cos theta by sine theta. Take LCM. What is the LCM in denominator? Sine theta. Then cross multiply sine theta minus cos theta. Then if you reciprocally sine into sine square theta, then cos theta into sine theta minus cos theta. Same way here also cos into cos theta, then sine theta into cos. Okay, here what is the common? If you see here, sine theta cos theta is here. Here cos theta sine theta. But if you see a plus changed as a minus. How? When we are interchanging in the a minus b, in a minus b, when we are changing b minus a into a minus b means minus will be common. Okay, the same way here also, what happen here? So when you are changing this cos theta minus sine theta, minus sine theta minus cos theta in bracket. So minus is changed, plus changed as a minus. But here this sine theta cos theta is a common they have taken. And sine square by cos theta, cos square by sine theta. Now again LCM. So sine cube theta minus square. You know what is a cube minus b cube formula? Yes, a minus b, a square plus b square plus b square plus ab. Okay. Now what will happen? This sine theta minus cos theta, this sine theta cos theta cancel, and then this sine theta cancel, and then sine square theta plus cos square theta will become 1, this one will become 1, and this both will become 1, this both will become 1, and 1 plus sine theta cos theta by sine, and separate it. If you separate this 1 by sine theta cos theta plus sine theta cos theta, this both will get cancelled. 1 by sine is nothing but secant, 1 by cos is nothing but cosecant. Sorry, 1 by sin is nothing but cosecant. 1 by cos is nothing but secant. So secant theta cosecant theta plus 1 will be the answer. That is, we have to prove the RHS. So this is very important sum you should practice. So here you are applying a cube minus b cube formula. Here when we are taking out interchanging this one sin theta to minus cos theta, then the plus will become minus. These two parts you have to remember in this sum. Now next we see the fourth one. Fourth one is very easy. 1 plus secant a by secant a is equal to, you have to prove sin square a by 1 minus cos a. How to prove secant A? Convert again into cos. So 1 by cos. Secant convert into cos. Take LCM. So what will happen? Numerator cos A plus 1 by cos A 1 by. Then cos A cancel, cancel. So cos A plus 1 is a, you got the, what is that? Cos A plus 1 you got the what? LHS. Keep. Now take RHS. Sin square A, how we can able to write? Sin square A we can also write it as a 1 minus cos square A. 1 minus cos square A is nothing but 1 minus cos A into 1 plus cos A. So 1 plus 1 minus cos A, 1 minus cos A will get cancelled. Then 1 plus cos A will come. Then LHS will be equal to RHS here. Okay. Now, if you see the sixth sum also, here root over is there. So, whenever root over is there, you take the conjugate 1 plus sin A, because sin A we can't able to convert into again any other terms. So, if it is cot, tan, cosecant, secant, we can convert as a sin or cos. Okay, but here sin A. So, take rationalizing factor. What is the rationalizing factor of 1 minus sin A? 1 plus sin A. So, 1 plus sin A, 1 plus sin A. Then what is the formula you have to apply here? Then root over 1 plus sin A whole square. Square and root will get cancelled. Then 1 plus sin A. Then root over 1 minus sin square A. What is the 1 minus sin square A? Cos square A. Then square and square root will get cancelled. Then 1 plus sin A by cos A. Then what will happen? 1 by, separate it. 1 by cos A is secant. Sin A by cos A is tan. Secant A plus tan A is the RHS here. You got the RHS. This is very important, sir. Okay. Now let me see the let me see the next sum. It is the sum is very little. This is also very important. The same type of sum is there in example. Please understand. So now, if you, for example, first one is cos A minus sin A plus 1 by cos A plus sin A. It is not possible to convert as A, but we have to get cosecant and cot. How is it possible? We have to divide whole term into sin A. Whole numerator also sin A, denominator also sin. Then when we are dividing cos by sin, it will become cot. Sin by sin 1. 1 by sin cosecant. Same way cos by sin cot, sin by sin 1, 1 by sin cosecant. So now if you see here, if you take the conjugate of this one, here cot plus 1 minus cos A. So conjugate of this one is cot A minus 1 minus cos A cot A. Here what formula will apply? A minus B whole square. So A minus B whole square formula. Okay, means minus of minus will become plus. Here down is A plus B, A minus B, means A square minus B square. Okay. Now when you are doing this one, A square minus B square, got here A minus B formula apply. What will happen? A plus B plus C whole square formula. A square plus B square plus C square minus 2AB plus 2AB, because minus is a minus 2AB. So plus 2BC 2CA. A plus B plus C square formula apply. Down also apply cot square A minus, here A minus B whole square formula apply. 1 plus cosecant square A minus 2 cosecant A. So now remove the bracket. If you remove the bracket, here 2 cosecants are there. So what will happen? 2 cosecant square. Here this is a cosecant square A. So cosecant square A will become 2 cosecant square, because cot square plus 1 is cosecant square A. Then cosecant will become 2 cosecant square A. And then here 2 cot A cosecant A and minus 2 cot A minus 2. Here all 2 is the 2 cosecant is the common. Okay, here in this 2 cosecant A is the common. So what if you take out cosecant A minus cot A in this common? Here 2 is the common, cot A minus plus cosecant A. That you take outside, cosecant A plus cot A. Then 2 cosecant A minus 2 will be there. So here this will become 1 plus cosecant square A will cosecant square A, 1 plus cot square A will become for you 1. So minus 1 minus 1 minus 2. So minus, if you take outside 2 cosecant A minus 2. So 2 cosecant A minus 2 will get cancelled. Therefore cosecant A plus cot A. This is very important. So please try to, you can do any other method also. It is not compulsory you have to do this method only. You can, so many methods are to prove LHS will be equal to RHS in the trigonometry. Let me see the next sum. This you understood. So next is, this is very easy. Only in this chapter, third and sixth sum will be little for you. Third and sixth sum will be little difficult. Sin theta minus 2 sin cube theta. What is the common in this? Sin theta is a common. And down also cos theta is a common. And 1 minus 2 sin square theta, 2 cos square theta. Apply in the place of cos 1 minus sin square theta. Then remove 2 minus 2 sin square theta minus 1. Then 2 minus 1 will become 1. 1 minus 2 sin square theta, 1 minus 2 sin square theta cancel. Sin by cos is tan. Then LHS equal to RH. This is only 3 steps. Now this is also very easy. If you seeing only whole square is here, then what we have to do? We have to apply a plus b whole square. Here also a plus b whole square to get 7 plus tan square plus cos. So sec sin square a plus cosecant square a plus 2 sin a cos a is a sin a plus cosecant A whole square. Same way cos square A plus secant square A plus 2 cos A secant A is a plus B whole square for this one. So now as we know that sin plus cos is 1. Okay. Cosecant, what will happen here? Cosecant square, also write it as a 1 plus cot square. Yes. Cosecant square also we can write as a 1 plus cot square. That all. And then secant also we can write as a 1 plus tan square. Then here if you see cosecant we can write as a 1 by sin. Same way secant you can write as a 1 by cos. Then cos cancel, sin cancel. 2 plus 2 will be there. Here 1, then 5, 6, 7. And 2 cot square tan square A. 7 plus tan square A plus cot square A. Then you got the RHS. The next one is cosecant A minus sin A secant A minus tan A equal to, you have to get 1 by tan A plus cot A. Here it is not possible to get LHS equal to RHS directly. We have to find out LHS value separately and then RHS value separately. They both should be equal. You will get equal. If you see why, because here 1 by tan plus A is denominator is A. So it is not possible to get directly. So first cosecant A, first prove 1 by sin. Convert as a whatever cosecant apart from sin and cos, rest all whatever the ratios are there, convert as a sin and cos. So cosecant as a 1 by sin as a sin only. So take LCM 1 by sin square A by sin A. Then sin by sin square cos square A. And you come this side, same way secant means 1 by cos. Then 1 minus cos square A by cos A. 1 minus cos square A is nothing but sin square A. So 1 sin cancel, 1 cos cancel, sin A cos. Now 1 by tan A plus cot A. Whenever the denominator is having the binomial, take it as a uh, rationalizing you can take, or you can convert as a tan into sin A by cos A, cot into cos A by sin A. Then if you take this one reciprocally to it, take LCM sin square A plus cos square A sin A. Then reciprocal and sin A by cos A sin square. This is 1. So here LHS will be equal to RHS. And the last sum of this exercise, 1 plus, there is a, we had to prove 3 terms here. 1 plus tan square A by 1 plus cot square A is equal to 1 minus tan square A by 1 minus cot square A whole square is equal to tan square A. Okay. So how to prove this one? 1 plus tan square A by 1 plus cot square A. You can take 1 and 3 or 2 and 3 or 1 and 2. You can prove anyway. But it is very easy. 1 and 3, 2 and 3 will prove. First we'll take 1 and 3. We'll get, if we take 1, we'll get third one. So 1 plus tan square A by 1 plus cot square A. In exam they will ask only 2 parts, not 3 parts. So but tan convert, as I told already, convert whatever in terms of sin and cos, it will be easy. So sin by cos. Cot is cos by sin. Take LCM, cos square plus sin square by cos square A. Sin square plus cos square A by sin square. Then this both cancel. Then 1 by cos, 1 by sin. Then what happened? Reciprocal 8 sin square by cos square is nothing but tan square. You got the third. Same way here 1 minus tan, 1 minus cot. So here you can prove it as a, here what means whole square is a. First you take it as a minus b whole square formula. What is a minus b whole square formula? 1 plus tan square a minus 2ab means 2 tan a. Same way down also 1 plus because whole square. So 1 plus a square plus b square minus 2ab. Now as we know that 1 plus tan square is nothing but secant. 1 plus cot square is nothing but cosecant. So secant square a minus 2 tan a by cosecant square A minus 2 cot A. So now again convert as A our sin and cos. Secant is 1 by cos. Tan is sin by cos. Cosecant is 1 by sin. Cot is cos by sin. Now take LCM. What happened? Cos square A. Then 1 minus 2. 1 cos is already existed. So 1 minus 2 sin A cos A by cos square A. Same way 1 minus 2 sin A. This 1 minus 2 sin A cos A cancel. Then this reciprocal it sin square by cos square A. You can take it as a tan square A. Then 1, 2, 3. 1, 2, 3 and 2, 2, 3. We can able to prove like this. So these trigonometric identities are very important sums. The fifth section practice one or two times, three times, more than that also no problem. So I hope you all understood by using the identities and ratios. This is very important exercise for your 3 marks and 4 mark sums. Thank you students.